chapter 4, question 4 on this exam. This question asks to determine the approximate shape of the histogram. First of all, we'll just kind of review what does it mean to be symmetric. Well, that would be right, same on both sides. So that's that bell shape. That don't look bell shape. Uniform. Uniform would be a graph that is straight across, right? That's not straight across, so that doesn't work. Skewed left or skewed right is what we're left with, or what's remaining. So the skewed left means that to the left side there is an outlier. Remember, that's the left is indicating the outlier, and that's what's happening here. The left side is kind of the lower end. That's where an outlier is. So this one is skewed to the left. Now, right skewed would be similar, but basically just flipped, where you'd have, it'd go up, and then we'd get some kind of outlier out here to the right. Okay, so just be able to know the difference between these three types of skews. I mean, it's pretty much got to be one of these, right? Because if it's not symmetric, it's got to be skewed or uniform. Anyway, those are the only ones we looked at. All right. For question number 2, second question on this page, question 5, we have to do two things. So looking at the end, we have to explain our reasoning, and that will determine, really more than anything else, the rightness of your answer. But what we're given is these numbers represent the home runs that Barry Bonds hit in the first 18 years of his Major League Baseball career. They're listed below. So I guess we could assume they're a sample. Doesn't really tell us. It's not all his, maybe. Find the mean and median. So that's what we're asked to do. We need to find the mean and median. We'll do that with our statistics calculator. And then round the mean to the nearest whole number, just the mean to the nearest whole number. Which measure of central tendency is best? Okay, so first, I'll just, they'll only give us one line, but we'll just label over here. We're going to find the mean and the median. And then we're going to have an explanation of which ones we chose. So we'll go over here to our statistics calculator. We're going to use the statistics part. And again, I'll go down one more. Remember, these are the 4 that we will be using throughout the course primarily, as well as the regular calculator part. We need to put in our values, so we start doing that. And each will have a frequency of 1. That'll work just fine. I'm just going to go across the top row, 24, 19, 33, 25, 34, 46, and 37. So I find it helpful when I say them and do them. 33, 33, 42, 40, 37, 34, 49, 73, 46, 45. And we'll remember, we kind of see there's 2, 4, 6, 8, 10, 12, 14, 16, 18. We put in, well, they told us 18. Okay, so maybe just read. But when we do our statistics, we want to make sure we've got all 18 in. It's always a good to come back and take a look at these. And I want to thank you guys for working through the calculator. I was seeing some of you do this. I go, how did they do that? Big window over here, right? It's a lot easier to see, and we can check that we've got all our values in there. Because if one value is missing, or if we transposed a number, we're not going to get the value right. And it's like, well, where did that come from? And there's no way to really check, right? Because you don't do a screenshot of this. So make sure you do that check. What do we do next? Oh, here, what we want to do is we want to go over to stats. So we arrow all the way up, and we go to stats, we execute, and it's going to give us all. We've got our 18 number of data points. That's good to check. We've got minimum first. We've got the medium, actually, is what it gives us first, right? Median. 35.5. So let's go ahead and write that down. Okay, and then where are we? We're looking for the mean. And this is the population mean. However, notice the sample mean and population mean are the same because the calculation is done the same way. And they want us to round to the nearest whole number. So 36 with the 5 next to it becomes a 37. Okay. Which one is better? Well, a lot will depend upon how you explain it. As we were entering in the numbers, or I was noticing, I sort of focused, this one is kind of way out there. So with that as an outlier, it's almost double. I mean, it's more than double some of these, but 33, you double that, it's 6, so it's more than double a lot of these. However, you did have some others in the 40s. But I would go with one answer that would be correct would just be to say that the median is best. Because outlier 73, and identify that, something like that. Now, remember, we can kind of analyze that with this calculator to see if there's really an outlier. Some of you may have said, okay, let's see if this is really an outlier. So we come up. One way to do this is you could go to the graph and we could do a box plot. Remember, interquartile range stuff. Actually, this one gives us the interquartile range. We could kind of calculate, but the box plot shows us that the third quartile is 45, first quartile is 25, so the interquartile range is 20, right? 45 minus 45 minus 25, that gives us 20 as our interquartile range. Multiply this by 1.5, and we're going to get 20, and then half of 20 is 10, so that gives us 30. If you take 30 plus 45, you get 75, so that's technically where the outlier starts. 73 is not technically an outlier, right, according to this. So I would accept as a correct answer an alternate. If you said the better one, mean because no outliers. Now the test key has this the median, because it counted 73 as an outlier. It gives it some skew, let's put it that way, but technically it's not an outlier because it would need to be 75. Okay, so I'll accept both of those, but again, it's the reasoning you put. It's why you tell me. You can't say, you can't mix them. Okay, median is best whenever we have an outlier. The mean is better whenever there are no outliers. Okay. Now let's go ahead and take a look at number 6. We've got these, it's multiple choice here. Student receives test scores given there. Final exam is 88, homework 6. Each test is worth 20%. Final grade 25, final exam, so forth. What is the student's mean score in the class? This is a weighted mean, right? They're weighted by these percentages. And so what we need to do is take each of the scores times the corresponding percentage. So we're going to want to take 62 times 20%, or 0.2. Again, you get the 0.2 from dividing by 100. we're going to take 83 times 0.2. We're going to take 91 times 0.2. The final exam was 88. It has a different weighting. It is 25%, so that's 0.25. And then the homework, which was 76 points, is weighted at 15%. And then we're going to add all these together, and that will be our weighted mean. Because if you add all these decimals together, you will get 1 or 100%, right? So you would take this and divide by 1. It stays the same. Okay, so we're going to do that. And then also show you how you could do it with the, well, actually, let me do this. Let's go to data. I'm going to come up here and we're going to clear it out. Let's confirm. Oh, what do I have to do it here? I can't just, it's not a touch screen, right? So we're going to confirm. I forget about that. What I'm going to do is I'm going to put the value in here, 62. I'm going to put the frequency as 0.2. And then I'm going to do 83 and a frequency of 0.2. Whoops. Gotta make sure I get them in the right spot, because sometimes it jumps around. There we go. Frequency of 0.2. 91. Frequency of 0.2. Now, while I'm saying this, if you wanted to put in 20s instead of 0.2, you could do all that. Just at the end, you would have to divide by 100 because you're using percentages. And then 88 times 0.25. The thing I like about this is that it's exactly what we got set up over here, right? And it'll, and when we're done, we're going to get a mean. The weighted mean actually is what we're going to look up. So we've got all our data in here. It's weighted. We can do a check here. 15, 20. Okay, it's all looking good. Now we go over to stats, and we just look, what is the mean? It's going to be the weighted mean when we do it this way. So we just have to arrow down, and there's our mean. It's 80.6. There's C right there. That's our answer. Not bad. Just made a C or a B, right? 80% usually is a B. But yeah, that's a way you can do that using the data feature, and I think that's a great way. You could also do it manually, just like this, and then add it together. You would still get your 80.6. And if you're more comfortable with that, and again, you remember, if you're bored with what I'm doing, you can always fast forward times. But see here, this is where I might make some problems, right? But I just want to show you it's exactly the same thing as doing it by hand. Plus, and the thing is you don't really want to do these individually, write them down and then re-enter them in. See, this is already getting confusing to me, because it's all on the line and it's hard to check, but I think I've got it right, and we'll come up with the same answer, times 0.15, and then if we execute it, there's our 80.6. Same thing, right? We could do just kind of the calculation that way, or use the tools. All right, let's keep going. Find the sample standard deviation. So remember, this is key part. This word sample is so important because there are two standard deviations, one for the sample, one for the population. We're given the data. In this question, you might be asked different things, but you'll be given some data and asked to find it. So, you could kind of try to guess at it, but let's not. Let's go back here to our stats. Let's go over to the data that's clear, and we'll confirm, and let's just put in our numbers, and we'll just do each of these as a frequency of 1. Oops, 28 and 47. Okay, and 7, 9, 12, 14, 20, 47. 15 and 42. Okay. So now we come over to stats, and we just need to look it up, right? We come down here, but be careful here. There's a standard deviation, but don't be fooled. That little Greek symbol means it's the population. And then you come down here, the sample standard deviation, 17.8. 17.8 right here. Now notice they weren't too terrible to us. The standard deviation, if you were to round this, it would be 16.8, right? That answer's not here. They have a 16.6, not even 16.7. So, oh, it's close enough. No, it's not. It's not close enough. It's different, and it's also the wrong standard deviation to use the population. You need to use the sample standard deviation, okay? So even if it's just off a little bit, do a double check. Sample standard deviation, okay? And it's nice, it'll say it right here. All right. A few more questions, and we'll just keep rolling along. So the mean score of a competency test is 79, average score 79, with a standard deviation of 5. Use the empirical rule to find the percentage of scores between 64 and 94. So empirical rule, just remember that's the one that says 68% of the data is between one standard deviation above and below. 95% of the data is 2 standard deviations above and below, and 99.7% are 3 standard deviations above and below. So we have to figure out what this is. So the mean is 79. Let's draw a little picture. 79 is in the middle, and then we start adding the standard deviation to it until we get to our numbers, or subtracting to get down to 64. So 79 plus 5, that's going to give us 84. That's not the right number yet. Add 5 more, you get to 89. That's not 94 yet. And add 5 more, and you get to 94. So this is 3 standard deviations above. And if it's 3 standard deviations below, then we're going to focus in on this. That's really all it could be with these values we've given. So the 64, subtract 5. So here we're adding 5. When we go down the other way, we're going to subtract 5. That gives us, what, 74? Take 5 more, you get 69. Not quite there. And then the last one will be 64. I didn't give much room, but, and that's that number. So that also is 3 below. 3 below to 3 above. That's 99.7. Okay. Number 9, find the z-score of the value 57. So that's a data value when the mean is 77 and the standard deviation is 9. So what you should have in your notes, or remember as well, is that the z-score is going to be the data value minus the mean over the standard deviation. So for this question, the data value is 57. The mean is 77, and we're going to divide that by 9. Now you see right away you're going to get a negative number, right? Because you're below the mean. So you could say, well, B can't be correct, and so it has to be negative. And now we do the calculation, and we can just do that with our regular calculator, calculation calculator. Let's clear that. Clear. No. How do you clear that thing? Well, anyway, it's not a big deal. 57 minus 77. Now don't just divide here. Let's enter, that's what we get, and then now divide that answer by 9. Make sure you're getting the order of operations. Let's see if that would have worked. 57 minus 77. Divide. See, yes, it's on. I like this. It's going to show you you're only dividing the 77 by 9. You can already see that's not going to give you a correct answer. So just make sure you get your order of operations, and it wouldn't give you one of the values. That's what's nice about multiple choice. It's negative 2.222. So that's going to be C. I guess I haven't been doing this, but maybe it's nice to kind of come back and, okay, let's see, that's A. But if you circle it, I'll work with you. I'm going to look over the whole forms because sometimes you got to write things out, right? So we'll get you. Don't worry about form and everything. Our last question is pretty straightforward. We actually don't even need the calculator for this one. We've got a graph here. Midpoints A, B, and C are marked on the histogram, so they're marking them here without calculating, because really you can't with this that much. Match them with the indicated z-scores. So here's our z-scores, and so we've just got to match, and it's just kind of knowing what's going on here. So we can see sort of the middle, right? The median, the median. The mean primarily is what we're using with histograms, is kind of that's got to be B, and a z-score is going to be 0. Okay, so I say, that's got to go there because that's the mean. Anything below the mean is negative. Anything above the mean is positive. Well, we got a negative one here, so that's got to be this one, 2, 3. Yeah, it's okay. We only got 3 values. And then C's got to be the positive one. Put a little decimal there. So we got them matched up, but then there's another question. Which z-scores, if any, maybe none, would be considered unusual. Unusual means they're further from the mean. So the mean is never unusual. That's the average, right? That's the usual. The further you get from the mean, then we are unusual. The basic rule, though, is, so you'd say, okay, the 2.03 is the furthest, so that's got to be it. But also the rule was, they came up with, if you're below -2, or some value less than -2, so z's less than -2, or z's greater than +2. So you're on either side. I don't know, that's not a very good drawing. Here's -2, here's 2. Anything outside of these is going to be unusual, and so 2.03 is an unusual value. So which, if any, z-score is unusual, z equals 2.03, and that's a perfectly fine way to do it. So we got all our answers matched up. Don't worry about this line. I don't know how you would put much there. So that's our test. Review it, and you'll do well. Thank you.